So we're going to get started with our final track of the day. And we have three wonderful partners, BAE Systems, L3 Harris, and Hysos Tech are going to be presenting on their pro add-ins and analysis. So I'm going to hand it over to Sam St. Leifer and Darren Stell from BAE Systems, who are going to be talking about GXP integration with Esri, providing a unified view for DoD customers.
So my name is Sam St. Leifer. I'm here with Darren Stell. We're with BAE Systems, and we're going to talk a little bit about our integration with ArcGIS, specifically Esri Portal. Just a couple slides, then a video, and then I guess any questions. So this first slide here is showing that overall we've had GXP, which is our software. We have Socket GXP as the desktop product and GXP Explorer, Platform Explorer, among others, as our server-based solution. And for a while we had ArcGIS or Esri going down one route and GXP going down the other. And so this is GXP Explorer, just a really brief overview slide. It's a COTS application, and it's a search and discovery and indexing tool. And it does have lightweight viewing capabilities with all of your GeoInt data. So Socket GXP is our desktop software. And what you're looking at right here is a bunch of different screenshots showing our different capabilities. In the top left is our connection with ArcGIS Pro. We call it SFA, Socket for ArcGIS. For a long time, we had it for ArcMap. Now we have it for Pro. Its main use is with stereo feature collection. And the rest of the screenshots are just showing our 3D LiDAR capability, our GRG capability, and SAR on the bottom left here. So this graphic here is to visualize kind of what we were showing on the first slide, where for a long time we had Esri going down its route, we're going down our route, and we had a lot of common customers. But now starting in, I guess it was back in 2019, that wall came down, and now the two can talk to each other. And that's what we're going to show. So we have three different use cases that we're going to show. It's not limited to this, but it's three good examples of what we've done. So the first video example, it's actually all one big video, but the first video example is showing the direct export of data from GXP Explorer platform to Portal for ArcGIS. So if you're not familiar with it, iStore Explorer, I showed it in the beginning. It's that index and cataloging tool that shows all your GeoInt data. You can take that and push it to Portal for ArcGIS. Is either a web map or a WMS, which we'll show some of in the video. The second example is a direct export of Socket GXP content to ArcGIS Portal. So this is on our robust desktop application, on our legacy tool where many analysts or soldiers are used to working. And without having to hop around to different software, they can put what's in their screen in their Multiport, which is the part of the Socket GXP tool, directly in as a web map into Portal. And finally, the third part of the video is cataloging Esri services. So I'm sure many of you are familiar with Esri services. You might be publishing out, you know, a couple a day, or you might have hundreds of them sitting around in a list in either your portal page or your server page in the root directory there. Well, what we've done is leveraged Explorer's existing catalog and indexing tool and displaying on a map and combined that with Esri services. So it will take all those, combine them on a map, and show you footprints of all the services. So where do my services overlay with my other GeoInt data? And next up is the video. Click play, and I'll pause it as I go through to describe some things. And I guess if anyone has questions, I'm not sure what, Heather, what the format is, but if anyone has questions, they can just, I guess, ask while I'm going through. we have a little intro here. Fast forward a little bit. So this first part of the video is showing pushing from GXP Explorer to Portal for ArcGIS. So what we're looking at here is the list page. We did a query for, so you can see there's some map servers, there's some terrain data and some imagery. And from within this view, with click of a button, which click the button right there, published it to Portal. And the video is a little bit fast forward for demonstration purposes, but you can see that that data that was in the list page in Explorer is now in the content page in Portal. And this is beneficial because a lot of our mixed customers were wanting to do this, or were hopping around and taking a day's worth of work to get it from one software to the other. And once it's in there, it has full Portal capabilities. You can share it out. You full metadata here saying, okay, differentiate that it's coming from GXP as opposed to ArcGIS. So there's tags already automatically created, and there is a link back to Explore, which I'll show in a second. But this opens it up. You can view the image on a web map, and you can open it up in GXP WebView, where the actual image data is owned. So you can perform some more robust photogrammetry and mensuration here. So the two are synonymous and talking to each other here. And I'll click play. And now what we're looking at is Socket GXP. So I'll back up a little bit. And what I have here is all different kinds of data layered into Socket GXP. I opened it up here in what we call Multiport. And what we're looking at is all kinds of different Esri data layered on top of an image. So we have an image, we have a geodatabase, file geodatabase, and a feature service all layered on top. And the user makes a traditional product with the GRG and a traditional template, but instead of maybe pushing it out to PowerPoint or saving it off to some other system and uploading it to Portal, directly here from Socket GXP, from our publish button, you can publish it directly to Portal from this view. And what you see is what you get. So what you're looking at here will be in Portal as a web map. You saw it was completed. Whoops, skipped a little too fast there. Sorry about that. Let me go back. So now it's completed. It's in Portal details page we're looking at here. Open it up in the map viewer. And again, you see that product on top of the base map. Sorry about that. It keeps clicking. Back it up. Okay, there it is on top of the base map. And also we can open it up back in web view again, where the image metadata is owned. So everything's a little bit more robust there. Finally, I'm going to show cataloging, displaying Esri services in Explorer. So right now we're looking at the map page, and I'm going to do a query for show me where my Esri services overlap with my imagery. I'm going to overlay it on the map, see if it's applicable to my AOR and makes sense, and then I'll open it up in WebView and do some exploitation. So I'm going to do a quick search here, and you can see those green icons are Esri, the red are imagery, is imagery. And I'm viewing the service to make sure. I want to overlay it real quick and view it before I exploit it. And right now I have the image on top of the base map and the cataloged Esri service layers coming in there. And I zoom in, I check it out, and it looks good. Unified view. So we're currently working, there might have been a slide on it that I skipped. We're currently working with the Army on something called Unified View, which involves everything I showed you here and more, and other software vendors, and how we can bring it all into GXP Explorer and Socket GXP and layer all of that Esri data and display it. We're actually working on this right now with you guys, Esri, actually, and other vendors. But yeah, we're just trying to reduce the swivel chair problem that the user currently has software hopping around GXP, Esri, and other third-party software, and we're trying to bring it all together. And I think this is definitely a huge part of that, what we showed today.
Okay, great. And you do have your, I think on the first slide, is your contact information for both you and Darren. If anyone has any further questions, feel free to reach out to them. Thank you both. And I guess the moral of the story is always have a backup presenter for you in case you get any feedback. So good thing we had you too, Sam.
Yeah, no
thank
worries.
you. Thank you both. So next up we have, so if you wouldn't mind stopping your presentation, and we'll let Megan Gallagher from L3 Harris Geospatial to share her screen. She's going to be talking about their add-in for ArcGIS Pro around SAR analysis. And I can see your screen, Megan, so go right ahead.
Fantastic. Can you hear me as well?
Yes.
Sweet.
Thank you.
All right. Oh, go ahead. Well, good afternoon, everybody. My name is Megan Gallagher. I'm a solutions engineer with L3 Harris Geospatial, and we're going to be going over the NV Starscape Analytics. And I'm actually really excited to be doing this because today in the conference so far, there has been a lot of talk about SAR, or synthetic aperture radar, or InSAR. And so I'm really excited to see this sort of all tie itself together pretty neatly. First off, a little bit of history. Harris, now L3 Harris, has been a successful partner of Esri for over 12 years. L3 Harris has worked at the engineering level to seamlessly integrate our NV workflows into the ARC framework. We're committed to support desktop, enterprise, and cloud offerings on the Esri platform. And NV Starscape Analytics, and sort of a total of all of this, is an example of that commitment, providing analyst workflows for using synthetic aperture radar, or SAR, to operate within the ARC Pro environment. So since SAR was brought up so much, I don't think I need to go too much into why it's such a useful tool, but I'll do a little bit of it. First off, this is a beautiful SAR process that is one of the things that tends to scare people away from using synthetic aperture radar. And that is, in the beginning, it's sort of difficult to understand what's going on. It's complex, literally. It has both real and imaginary portions. And so that's where the analytics come in, is they make it a lot easier just to have your data, put it into the workflow, and then get the output results that you need and that you can use very easily. And there are SAR sensors out there, more and more every single week, it seems. Added to this chart, we have Capella, Novasar, ICEYE, future satellites that are coming out. They're just increasing just every single month or so. It's pretty amazing. And with that, we're getting an increase in spatial resolution. This is starting from a meter, but it's sub-meter now. We're matching optical imagery. You have an ability to acquire multiple images of the same area in a short period of time, because SAR, unlike optical sensors, can see during the night as well as during the day. It can see through clouds. And so you now have a reliable sensor that can go over your area that is no longer triumphed by condensation. There are also freely available sensors. So in this case, we have Sentinel-1 by the European Space Agency. So you're able to get free SAR data to use in your processing. All of these combined together give you the capability in building a multi-temporal stack of data with a time interval of less of a month, free of charge, which is fantastic for any kind of monitoring or just viewing an area that might have a lot of cloud cover most of the time. A little bit of science about that cloud cover is the difference between the optical sensors and SAR sensors. So optical sensors are passive, meaning that they are reliant upon the sun for being able to see what's on the ground surface, and unfortunately, or I suppose fortunately, the Earth has clouds. They supply us with rain, and they also mess up our images when we're trying to see what's happening. SAR, on the other hand, is an active sensor, meaning we're not reliant upon the sun, and instead the energy comes from the satellite itself. It interacts with the ground surface, and then it bounces back to the satellite, making it so we can ignore things such as smoke, clouds, nighttime, giving us the ability to see when things are happening. And some of the examples I'll be showing later, such as during Hurricane Dorian over the Bahamas. Another one was during the Camp Fire. So we can actually see and react when events are occurring. So in other words, it gives us greater availability, greater repeatability, and accuracy of calibration. If you've worked with SAR in the past, it might have looked like this. From my expert opinion, there's a road on the left-hand side, and there look to be some fields that are probably in the middle of this image. However, let's look at something a bit more modern. And so now we can see that there's definitely a road, as well as we can see that there are wind turbines in this image, which you could put into a classification schema or even deep learning to train it solely off of the SAR images to pick up those kind of features. So what kind of problems can you think of SAR solving? You know, if you run into these kind of situations, SAR might be a really good thing to use. One is land use. It's commonly used for agriculture monitoring. Once again, those clouds making it so you can't see what's happening on the Earth's surface. In forest management, it can be used for biomass estimation and seeing if areas are being clear cut during specific periods. It's very good also for monitoring illegal deforestation. In engineering, it is well known for monitoring the stability of infrastructure, such as dams, railways, bridges, and buildings. And it is commonly used for natural disasters, such as earthquakes, flooding, and volcanic eruptions. So with my little science spiel done, let's jump into the tools themselves. So there are 10 easy-to-use Starscape analytics. You can see them here on the right. They already have a toolbox, and they're also refinement tools for ease of use. You can think of this as you do your entire process. Maybe some of the results need to be cleaned up a little bit. You don't need to rerun the entire thing. Instead, you can just change some of the parameters, and it'll rerun from by like 3/4 to finish when it was just doing the final classification parts. So you don't need to rerun the entire process to get the results that you need. The automated workflows are fit with best fit parameters, and it's completely data agnostic. What this means is if you have a SAR data and you bring it in, the workflows will read the data, figure out what it's from, if it's TerraSAR, if it's Sentinel, ISI, whatever you're using and whatever you need, and will automatically make the parameters in the background be the best ones for that sensor for the workflow that you have. So you don't need to worry about it. It's all already done for you. And with that, let's go and see what these analytics actually are. So there's a flood map tool, and this is the picture on the far right. And this uses images from during and before a flood to see the changes that are occurring and separate out flood water from water that is already there. So that image on the right is the one I was talking about earlier. It is the flooding that occurred in the Bahamas during Hurricane Dorian. So we were unable to get any optical images because there was a hurricane and lots of clouds in that region, but we are still able to get a flood map on the surface. There's image geocoding, which allows you to view and correctly geocode your SAR imagery, so you can actually see it in your screen and see what's happening there. Persistent scatterers, which is one of my favorites. This allows you to have a time series of SAR data to track surface displacement with millimeter scale accuracies. There are also 2 download tools here. One is Download Sentinel, and one is the Download Sentinel-1 auxiliary data. All you have to do is put in a shapefile, say, your time period that you're interested in, the certain products that you have, and you can download all the Sentinel-1 or the Sentinel-1 data that you need inside of ArcGIS. So you can just keep working on your projects. It'll start loading it in the background, and you can just keep on working. Next, we have change detection with my favorite example on this slide. Change detection uses 2 scenes, one from before an event and one from during or after an event, and looks at the change in between them and does an automatic classification. The favorite example of mine is this one of Burning Man. We've got a pre-Burning Man lovely desert. We have a co-Burning Man, or during the Burning Man festival here, and where you can see all the tents and artwork. And then we get an automatic classification at the end that's showing us these areas that have changed in between the 2. And we'll be going into this one in a lot more detail. Time series is if you want to go beyond just 2 images, if you need more than that. And this allows you to have a stack of images and to get statistical information from. This is commonly used for agriculture. Displacement map and DEM extraction are the same kind of process, but they give you different results. DEM extraction does just that with 2 scenes. You can get a high resolution DEM created in between them. Displacement mapping uses 2 scenes to show the displacement that has occurred between them, which is commonly used for monitoring earthquake effects and volcanic changes. Lastly, and something that's come up a lot today, is ship detection. So there's an automatic ship detection tool, which uses a single scene to find ships on water. Ships stand out clearly against water using SAR, allowing for quick and easy detection. Automatic identification systems, or AIS, can be used in tandem to compare between where the ships are and where they might have said they were. Here's a quick look at one of the tools in total. This is the flood mapping over the Bahamas example. So this takes a post-event image, pre-event images to build up a baseline. You can have an area of interest to cut down your processing time. You can use a DEM that's included, or you can have your own. There are a couple parameters here that you can mess with, but they are automatically filled out for the average best parameters. So most of the time you can just leave them alone. You choose your output folder and then you hit OK. And that's what was done for this Bahamas image right here. Another example is the time series tool. This one was using 4 Sentinel-1 images over the Philippines. Those were put into that little top box that says input file. And then the only thing that was done after was the output folder was set and we get our results. You can get a lot of statistical information as well as date information. So such as which date had the greatest amount of change. This workflow was actually used to monitor the river as it was starting to dry out in specific areas and we're able to see the sandbanks underneath. And I've done a lot of talking, but I do like showing an example. So here is a full workthrough of using this tool. So I'm going to the Starscape Analytics Toolbox. I'm choosing my post image, so my Sentinel-1 image during Burning Man, my Sentinel-1 image before Burning Man. I'm choosing my area of interest to cut down on that processing time. I'm leaving my DEM alone. Then I choose my output folder. Hit run, fade to black for ease of demo use, and we get our output results. And so when we're looking at this, you might notice something pretty interesting. On the left-hand side, we can see we actually have multiple classifications, and that's because one is automatically filtered. So you don't need to worry about filtering it afterwards. Instead, you can filter it during the process to get rid of the speckle that occurs whenever you do a classification. The results for this one also show different colors. What these are significant chains reflectivity increment, meaning that we're getting more reflectance back at the satellite. In this case, that relates to the tents in the artwork. Reflectivity decrement is areas where things have gotten flatter. Small scale change is actually leading up to the area of Burning Man, and that is caused by the tire track roads that are created. There is also humidity decrement and increment, and this is related to moisture changes that are found on the surface. Lastly, you also get some outputs that let you know a little bit of what's happening in the background, such as the ratio in between your images and the stability index that is showing the change that has occurred in between them as well. Grab my mouse back. All right, and with that, thank you. We are working at selling the Starscape Analytics in the ArcGIS marketplace at the moment, and we will let our Esri partners and distributors know when they're all available. And with that, I think we have some time for questions.
Thank you, Megan. So are there any questions from anyone? Either unmute yourself. We can do it that way, or feel free to use the chat. Okay, well, thank you so much, Megan.
Thank you.
If anyone has any other follow-up questions, they can feel free to email you at the address there. And thanks again for your time today. That was great.
Absolutely. Thank you for having us here.
All right. So moving on to the last presentation of the day. Last but not least, we have Sean Johnson from Hisos Tech. I hope I pronounced that correctly, Sean. And it looks like I can see your screen now.
Close. Thanks, Heather. You can hear me?
Yes.
Great. Thanks. I'm Sean Johnson. I'm a principal here at Hisos Tech. Hisos is an Esri startup partner. We're offering AI solutions, including natural language processing and computer vision techniques to extract meaning from combined human sketches and speech. We were founded to continue the work and bring to market a 10-year DARPA-funded solution envisioned by the Deep Green Project. Sketch Through Plan for Pro is an AI-based human-machine teaming workstation for accelerated decision-making and COA creation, or course of action creation, for planners. We leverage NLP and other AI capabilities to help guide planning for the warfighter or emergency management professionals. STP fuses the user's speech and sketch, simplifying the interface, allowing them to focus on the task of planning, not the interface of the tool. STP compresses the observe, orient, decide, and act, or the OODA loop, with fast, efficient, and high-quality planning data that drives tight adjudication loops, automated analysis, and wargaming, allowing leaders the opportunity to evaluate multiple options which lead to superior plans. STP is a technological advance for today's warfighter that enhances cognition by implementing military doctrine-driven AI-based task recognition that automatically perceives, I'll get there, automatically perceives the planner's implicit higher order intentions on the fly, generating tasks, task matrices, sync matrices, and other op-board products with minimal additional user input. It also generates standards compliant export files that integrate with and seamlessly drive simulators and C2 systems. So that's the overview, a lot of words. The best way to get this is actually to view the demo. So let me just jump into a live demo. Grab ArcGIS Pro here. And you should be able to see this. So I'm going to just go ahead and do this. And so what we see here is Pro, and we see the sketch through plan tab, I'd add in to Pro. It's other than this, it's a fairly clutter-free interface. And STP is a role based. So I'm going to start with S2 and just start adding voice and sketch COAs here. Armored Company Alpha. Stryker Company. Okay, so I added a couple of enemy units. Let's go to S3, and we can see the different roles here that are available. S3, S4, Fire Support Engineering, and S2. Alpha 269. Objective Wildcats. Main Attack, Seattle. Okay, so what you saw there was a straightforward natural language input for that plan, and that's the wow factor, but under the hood is where the advanced AI-based task recognition is happening. So I'm going to show my task pane, and we can see that the tasks were generated here. We have Alpha 269, following along axis Seattle to objective Wildcats. And we can start interacting with this interface if we want, or we can continue planning through the speech and sketch. But I'm going to leave this open so you can see the things that happen here. Clear. Try that again. Clear. Okay. And so now we see that that moved to attack to clear. I'm going to go ahead and approve that. And we can see that anticipated unit now has moved into that area. Let me add another bits here. Objective Bearcats. Okay, and what we can see here is that the task recognizer now offers additional potential tasks for that anticipated unit. So we can continue, fix. Okay, we'll add some more here. Actually, we'll go ahead and fix that. Okay. Bravo 115. Follow and support. Yeah, we'll just go ahead and approve that as well. And we see that Bravo 115 now anticipated unit is following Alpha 269. So let's do a few more here. Yep, so let's actually look at some of these things here. So as we look at the task details on here, we can see that we moved along a axis to clear, and we see that actually time is 0 to 1. So this is doing a sync matrix, task matrix, right? So the second one option was actually time 1 to 2. So we have all of the very detailed information that's happening in this task pane, as well as all the other units here. So I'll just add a few more just for fun. Company boundary 269 south. Company boundary 269 north, 115 south. Forward line of owned troops. Line of departure, line of contact. Attack helicopter. Assembly area alpha. We'll occupy that. Rotary wing axis of advance. Okay, so we can do all those sorts of things, and we can do, again, do more bits here. Destroy. Okay, so we can see all of those things. So once this is all done, you see how easy it is to create this. All of this very highly detailed information can then simply be exported to a product called C2 Sim. It's a CISO standard for interoperability with simulators and C2 systems. And what that looks like is this. When we click export, we see that it's a standard based XML system that gives us all of the pertinent information about timing, location, names, tactical tasks, and all the graphics that are associated with it, right? So once that is done, I'm gonna go ahead and launch something here real quick for you so you can see it. Once the export to C2 Sim is done, we can actually then bring those into any C2 Sim compliant simulator or C2. So let's grab this. You can see this. Okay, so actually let me jump in here real quick, jump over to my Cairo area, right? So we've built kind of a bit more complex battle plan here. And then once that's done, we actually bring it into this. This is a commercial available simulator called Sword. We can simply play that, and we can see that that goes through, and it simulates this battle where the friendly units are moving through and attacking the enemy, and the refugees are retreating. So I'm not going to go into any more of that, but that's the capabilities that can be had. One other bit that we can actually do, and I'll just move this real quickly here and talk this, right? So I can do something like this. We can have an interpretation list. So if I don't really know all of the names of things, I can build them notionally by saying, you know, friendly infantry, and then giving it an echelon and giving it designators, or I could say something like Charlie Company. Okay, so Charlie Company actually has a whole list of different Charlie Companies potentials that are out there, so we can choose that there. Okay, so let me pop back to my PowerPoint. Right, give a review here. So Sketch Through Plan has robust AI capabilities. AI-based task recognition automatically perceives the planner's implicit higher order intentions, generates tasks, task matrices, sync matrices, and other off-board products, and automated simulation feedback that guides planners and tight adjudication loops. NLP of spoken doctrine is the UI, so it's fast and intuitive user interface for inputting plans. It fuses the user speech and sketch for COA symbol laydown, orders of magnitudes faster than traditional and conventional UIs. And it's a microservices architecture, so it's extensible and open. And our commercial product is ArcGIS Pro, but in previous versions, we've integrated with directly into military systems like CPOF, C2PC, Tiger, in-vehicle JV5 systems, Boeing Tapestry, as well as with simulators like ModSAF, LG RAID, SWAP, and SWORD, which are both C2 Sim compliant simulators. Soldier benefits, this is enhanced cognition and performance because of the system complexity is reduced by automatically recognizing the intentions from higher level actions. The operator avoids traditional interface distractions and the soldier can focus on the task, not the tool. Reduced training on specific systems because it's optimized for higher level language rather than system specific commands. And system proficiency becomes a function of the user's tactical and doctrinal training and knowledge, not system unique training. And we believe this can improve wargaming by compressing the OODA loop, by enabling fast creation of high quality COAs for automated analysis and wargaming, provide leaders the opportunity to explore options resulting in the optimal COA, and the automatic generation of standards compliant data that can drive simulators and populate C2s or control complex systems. So we have over 4,000 2525 symbols and tactical graphics and tactical tasks that we recognize. The multi-step tasks are recognized automatically. Instant creation of the sync matrices and task matrices, role specific, which I show with engineering, fires, logistics, and like. Template-based opward generation completes that cycle, and the single button push generates the standard-based input for simulators and C2 systems. So you saw some of the interface here. We saw the basic toolbar. We saw the end best list for the optional symbols that you may want to place. You can choose to use the standard military symbol editor if you want with Esri. So that's always available there. And then we've got this task pane that I showed a lot about. And then there's the additional panes that we didn't get to show about. So those additional panes look like a task matrix is more like a drag and drop sort of Gantt chart where we can move these timing if we want to, or they'll be placed in the right position based upon the order that the order of battle there. A sync matrix, a task org. So you can actually build a task org for if you're a planner for a specific brigade or whatever, right? You can build your own task org so that you can then easily speak to things like, 137, and it would actually add that. We have a targets panel for the fire support officer, the fire support matrix, directed obstacles for engineers, an obstacle matrix, and then an ISR tab as well. So those are all additional product panels in the product. So the last slide here, status is a commercially available ArcGIS Pro add-in. We're working on getting it onto the Esri marketplace. Hopefully that'll be soon. We offer simulation modeling support, multi-domain planning capable because of all of the symbols that we recognize and all of the doctrinal based tasks that we recognized. So land, sea, and air. Real-time and remote collaboration for US and coalition partners because we can run this, run the core on server and have multiple ArcGIS Pro users accessing that same core, could be web-based users as well. We support form factors from handhelds to in-vehicle systems and all the way to large touch walls. This one here is a 30-foot wall that you see the picture of that we did it on. The applicability stands C2, simulation, training, or complex equipment in unmanned autonomous systems. So we've been given a direction by a couple of different partners and opportunities to look at using multimodal speech and sketch ability for interacting with autonomous, unmanned autonomous systems. So you saw the very focused military-based demonstration there, but public safety emergency management is on the roadmap, specifically when 2525 Echo comes out, because that will have a much expanded symbol set for those user groups. Decades of academic R&D, including the DARPA Deep Green project, and previously achieved TRL7 on product. So that's it. That's my contact information. And let's see if there was any questions for me.
Thank you, Sean.
Yeah.
Any questions for Sean? You can put it in the chat window. So we just have a couple minutes left before we finish. If there are no questions, then I'll close and just want to say thank you to everyone who tuned in today. It was a long but very vast day of a lot of different solutions from our partners, and thank you all for joining us. These tracks were recorded, so we will be posting them. If you didn't get a chance to see some of the other sessions, we will have these available fairly soon, probably within the next week. All right, thanks again. Thank you, Sean, and everyone have a great afternoon.